Hi, I'm May, and I'm the electrical engineer on this project.
I'm Callie, and I am the bioengineer on this project.
I'm Eric Obslager, and I'm the mechanical engineer on this project.
I'm Pooh, and I'm the bioresources engineer on this project.
Okay, so for our product, our challenge was to make surgeries safer. So we thought about the medical advancements and the technological advancements that we could use to accomplish this. So medical advancements are essential to the sustainability of future healthcare. And as the population continues to grow, the need for safe and affordable healthcare becomes more prevalent, obviously, and it's going to become a societal priority. So to accomplish this, we're going to need trained, capable surgeons, and that's what our headset is meant to do. Technological advances vary from medicines and apparatuses given to patients. So this is affected in the way that surgeons are using technology in the operating room.
Introducing Surgeon. As for engineers, we have come together to fulfill both of these goals by creating a simulation headset to increase the standard of surgeries. The device would be a virtual reality headset and controllers, running a program that can simulate operations realistically and display first-person, magnified third-person views of simulated operations in the video format. We are asking for $500,000 at a 10% stake.
Okay, so the main uses for our product would be that Surgeon would be used for a training or informational tool outside of the operating room. So surgeons could learn how to perform surgeries before actually performing them on a patient. So it has multiple functionalities. It would provide a hands-on experience. It would test safety precautions. It would train surgeons in operations, and it could play videos of operations pre-recorded so that surgeons could observe.
Okay, so there are many benefits we're expecting from this device. First of all, it'll reduce operational errors significantly because the device will provide better training and practice to surgeons. Also, it'll create a low pressure learning environment where surgeons would be less nervous to admit their mistakes and learn from those mistakes, since mistakes aren't as critical as when the surgeons are in real surgeries with real patients. And overall, it'll eventually create a better dynamic in the workplace as they learn to operate in their field.
Hi, I'm Callie, and again, I'm the bioengineer on this project. And in our product, which is meant to simulate virtual surgeries, my priority would be software. As a bioengineer, I work with, our goal is for it to be realistic and be able to simulate surgeries that seem real, engineering principles. So for the software would hold the capacity to simulate multiple surgeries, all surgeries except for emergency surgeries, since often they're unexpected or combine all like knowledge from other surgeries. So they would be learned through learning these surgeries, but obviously surgeons have multiple specialties, but we have software that includes surgeries from all these specialties. So once a surgery is selected on the device, the surgeon has the ability to magnify the body, zoom in where they need to, see the body parts that they're working on, and it's very realistic. And if the surgeon or the student makes a mistake, there will be like bleeding out, like actual things that would happen in the operating room, but they're not actually losing a patient. So it's really important that they're learning how to control and admit their mistakes. And at the end of their surgery, we have programmed the software to rank the surgeon on their performance and how delicate they were with their procedure or how well they performed their procedure. So overall, it teaches the surgeon how to be a better surgeon when working on their operation.
So as an electrical engineer on this project, I designed the complex circuitry. It is very important to have electrical engineers on this project because we design the electrical systems inside the device. The electrical systems involve power unit, battery levels, system sleep or standby states, etc., which are some of the very most fundamental components when making a device.
As a bioresource engineer, I work with the sustainability side of our product. We will be tackling both the problems of food waste and sustainability by using food waste bioplastic, which is essentially turning food waste into 100% biodegradable and compostable bioplastics to manufacture our VR headset. According to the FDA, approximately 31% of the food is wasted at the retail and consumer levels every year, and that 31% is approximately worth $161 billion. In addition to this, landfills, which is where most food waste ends up at, produce a significant amount of methane and groundwater contamination, which are classified as greenhouse gases. Our company is aiming to do our part by recycling those food waste into bioplastics instead of letting them go to waste. Essentially, we will be both helping the problems of food waste and greenhouse gas emissions. Our product will also cost less to produce, both in terms of energy and money. Compared to the traditional petropolymer, which is a material used to make normal plastics, our bioplastics will require significantly less energy to produce. Our production line will in turn contribute less to global warming compared to the typical plastic production line. We will also plan to cooperate with the FDA in order to manage some of the food waste that is initially going to the landfills and instead transferring them to our manufacturing department. By doing this, we will be saving money as we are reusing available resources instead of making new ones.
Mechanical engineers excel in the design and production stage of creating a device, as their experience lets them brainstorm a prototype and then determine what materials will be the most optimal for each part. As such, once told what the device needs to do, mechanical engineers would be best equipped to design the device and the materials required to construct it. In this case, the mechanical engineers would work alongside the bioresource engineers to create components of the headset that would be sustainably produced. They would also maximize the durability and comfortability of the headset while minimizing its weight. Finally, they would play a role in ensuring that the program is compatible with other headsets on the market. As suitable headsets are already readily available internationally, the full program would be made available for leading VR headsets. This would help with the overall accessibility of the device and make it available on a larger scale. For some hospitals that may not have access to funding available to spend on VR technology, operation videos from the program would be on inexpensive smartphone VR kits, such as the Google Cardboard. Finally, the videos from the program would be available to watch by themselves on any device.